Good morning, dear students. Today we are going to revise lesson number 7C from study of compound, that is nitric acid. In this lesson we are going to revise laboratory preparation of nitric acid using potassium or sodium nitrate, Ostwald process, physical properties of nitric acid, chemical properties of nitric acid, and test for nitric acid. Now, laboratory preparation of nitric acid. The setup for laboratory preparation of nitric acid is as shown in the diagram. The reactant used here are concentrated sulfuric acid, which is in liquid form, nitrate or chill saltpeter, which is in solid form, and the product obtained at the end of the reaction is nitric acid, which is in liquid form. Potassium nitrate, when treated with concentrated sulfuric acid at a temperature less than 200, it forms potassium bisulfate and nitric acid. Sodium nitrate, when treated with sulfuric acid at a temperature less than 200 degrees Celsius, it forms sodium bisulfate and nitric acid. Now let us see the introduction of nitric acid. Discovery. Nitric acid was initially called aqua fortis. In 1784, Cavendish determined the composition of nitric acid. Nitric acid occurs in free state and in combined state. In free state, it occurs during lightning discharge. Nitrogen plus oxygen gives nitric oxide. Nitric oxide, when it is reacted with oxygen, it forms nitrogen dioxide. Nitrogen dioxide reacts with water and oxygen to form nitric acid. In combined state, as it solves in minerals, example chill saltpeter, that is sodium nitrate, NaNO3. Bengal saltpeter, potassium nitrate, that is KNO3. Now nitric acid is highly corrosive in nature. If it accidentally falls on the skin, it reacts with the protein present in the skin to form xanthoprotic acid. Laboratory preparation of nitric acid from potassium or sodium nitrate. The reactant used here is sulfuric acid because it's a strong non-volatile acid and it is capable of displacing the more volatile nitric acid from the latter salt. Now concentrated HCl is not used in this process because it is strong volatile acid and it is not used to displace another volatile acid. Now the molar ratio is 1:1 in the formation of acid. Apparatus is made up of only glass because the vapors of nitric acid are highly corrosive, and being corrosive it attacks rubber, cork, etc. Temperature is maintained less than 200 because they may cause to damage the glass apparatus, further decomposition of nitric acid, formation of hard residual crust of corresponding sulfate, that is sodium sulfate or potassium sulfate, which being a poor conductor of heat stick to the glass and cannot be removed easily from the apparatus. Now pure nitric acid, if we see, it is colorless. Nitric acid undergo decomposition to form nitrogen dioxide, water and oxygen. The yellow tinge of nitric acid can be removed by bubbling of air or carbon dioxide by dilution with water. Identification of nitric acid can be done by treating copper with nitric acid, which gives copper nitrate, water and reddish brown fumes of nitrogen dioxide. Reddish brown fumes of nitrogen dioxide turns acidified iron sulfate brown in color. Now let us study the Ostwald process in detail. Now the first step consists of catalytic chamber, where ammonia reacts with oxygen in presence of catalyst Pt, and the temperature is 700 to 800 degrees Celsius. The product formed is nitric oxide plus water. The ratio of ammonia to air is 1 is to 10. Here 95% of ammonia is converted to nitric oxide. Second step is oxidation chamber, where nitric oxide combines with oxygen at 50 degrees Celsius to form nitrogen dioxide. So this is the reaction which takes place in oxidation chamber. Now in third step, the reaction takes place in absorption tower, where nitrogen dioxide reacts with water and oxygen at ordinary temperature to form nitric acid. So these are the three steps involved in Ostwald process. And the first step, the reaction, is exothermic because heat is given.
Who developed this process? Wilhelm Ostwald, a German chemist who received Nobel Prize in 1932. What is Ostwald process? It's using ammonia, a colorless alkaline gas with pungent smell which highly soluble in water to manufacture the nitric acid. What are the uses of nitric acid? Fertilizer, plastics, dyes and explosive like TNT boom. Process flow. Step 1. Ammonia oxidation. Ammonia and oxygen enter the catalytic converter which contains platinum gauze as catalyst and is converted into nitric oxide and water. The mechanism is as below. It operated at high pressure and high temperature, which 700 to 800 degrees Celsius. Step 2. Nitric oxide oxidation. Nitric oxide from ammonia oxidation is very hot. It is then passed through a cooling tower where its temperature is cooled to 150 degrees Celsius. Next, it is transferred to the oxidation chamber and oxidized to nitrogen dioxide at 50 degrees Celsius. The mechanism as below. Nitric oxide oxidation is operated at 50 degrees Celsius. Step 3. Absorption of nitrogen dioxide. Nitrogen dioxide from secondary oxidation is then enter the absorption chamber. Water is showered over it and diluted nitric acid is obtained by absorption. It is then recycled and combined with water and oxygen to produce a higher concentration of nitric acid. The mechanism as below. Modifications. It uses Nobel metal catalyst where platinum is upgraded to platinum rhodium gauze as catalyst. Platinum recovery system is introduced where it is made from palladium and is easy to be installed. And larger diameter is introduced.
Let us study the physical properties of nitric acid. It is colorless. It does not have any specific color. It has suffocating odor. Being acid, it is souring test. It is highly soluble in water. Boiling point is 86 degrees Celsius and melting point is minus 42 degrees. Now let us study the chemical properties of nitric acid. Now dilute nitric acid. Nitric acid reacts with water to form hydronium ion and nitrate. It is acidic in nature due to the presence of H plus ions. Dilute nitric acid, it has a strong oxidizing property. Concentrated nitric acid is poorly ionized. Now Whenever hot concentrated nitric acid is heated, it gives nitrogen dioxide plus water plus nascent oxygen. Now, nascent oxygen is highly reactive and unstable. Moderate concentrated nitric acid, it gives nitrogen dioxide, water and oxygen. Now, let us see the reaction of non-metals with concentrated nitric acid. Now, non-metals, they gain electrons, they are negatively charged and they form anion. Now, carbon reacts with nitric acid to form carbon dioxide, water and nitrogen dioxide. That means carbon plus 4 parts of nitric acid gives 1 part of carbon dioxide, 4 parts of nitrogen dioxide and 2 parts of water. Now, when sulfur is treated with concentrated hot nitric acid, it gives sulfuric acid, water and nitrogen dioxide. 1 part of sulfur reacts with 6 parts of nitric acid to form 1 part of sulfuric acid, 2 parts of water and 6 parts of nitrogen dioxide. Now, that means from volatile acid, that is nitric acid, we get non-volatile acid, that is sulfuric acid. Phosphorus, when treated with nitric acid, it gives phosphoric acid, water and nitrogen dioxide. 1 part of phosphorus reacts with 5 parts of nitric acid to form 1 part of phosphoric acid, 1 part of water and 5 parts of nitrogen dioxide. In case of metals, they lose electrons and form cations, they become positively charged. Manganese and magnesium reacts with cold, very dilute nitric acid. Magnesium reacts with nitric acid to form magnesium nitrate and hydrogen. Manganese reacts with nitric acid to form manganese nitrate and hydrogen. So, in both the cases, hydrogen gas is liberated. Whenever acid reacts with nickel, it forms salt and hydrogen gas is liberated. Now, nitric acid is an oxidizing agent. What is this oxidizing agent? Now, oxidizing agent always removes electron from the other reactant. It is an electron acceptor. Now, let us see the reaction with dilute nitric acid in cold condition and concentrated nitric acid. It's very important to mention whether the acid is dilute or concentrated. Now, copper, when treated with nitric acid, it forms copper nitrate, water and nitric oxide. Now, 3 parts of copper, 8 parts of nitric acid gives 3 parts of copper nitrate, 4 parts of water and 2 parts of nitric oxide. Now, when copper is treated with nitric acid, here we get copper nitrate, water and nitrogen dioxide. Here we have used 1 part of copper, 4 parts of nitric acid, we get 1 part of copper nitrate, 2 parts of water and 2 parts of nitrogen dioxide. So, the reaction between dilute and cold nitric acid differs with the formation of nitric oxide in case of dilute nitric acid and nitrogen dioxide in case of concentrated nitric acid. Test for nitric acid. Brown ring test is used for detection of nitrate, that is NO3 radical. In this, iron sulfate is treated with dilute nitric acid, which is again treated with concentrated sulfuric acid. It gives iron sulfate, water and nitric oxide. When iron sulfate is treated with nitric oxide, it forms nitroso iron 2 sulfate, a brown compound.